everybody hear me okay? All right, good, good. Thank you for coming out here on this absolutely gorgeous day today. We're going to talk about the OSIRIS Rex and the direct missions that visited several asteroids, and will be followed up by the HERA missions from the European Space Agency that will actually revisit one of those asteroids. There are a few meager handouts on the table back there on Artemis and the Apollo 50th anniversary. There's also another sheet there for the quiz, that if you are so inclined and you want to try to answer the questions, whoever can answer the most questions correctly, there's a prize. It's a very simple three-dimensional model of the Apollo lunar module and the Apollo command and service modules. So if you want to try to look at it, you can. I am a space cadet. I have been since I was 6 years old. I'm from northeastern Pennsylvania. I grew up doing Apollo. I'm probably amongst the last generation that remembers watching Neil Armstrong walk on the surface of the Earth. When I was in the 4th grade, the Apollo 13 incident occurred, and I wrote a report on it for my 4th grade classes. In 2021, my wife and I went to a 50th anniversary celebration of Apollo 13. It was at the Cradle of Aviation Museum in Long Island, New York. Grumman manufactured the Apollo lunar module in Long Island, New York, not far from where this museum actually is. And two of the Apollo flight directors, Jerry Griffin and Milt Windler, were at this event. And I had the opportunity to sit and talk with them for quite some time. And that report that I did in 4th grade is now autographed by both of those flight directors. I went to Penn State. I graduated in 1983. I interviewed at the center here in Cleveland and the Lewis Research Center before I graduated. They offered me a position in March of '83. I graduated in May of '83. I started working in June of '83. I retired at the end of December after 41 and a half years with NASA.
Good for you.
These are some of the projects that I worked. You'll notice that DART is up there, and we'll talk a little bit about it as well. I worked on communication satellite we launched on the shuttle, 2 weather satellites for NOAA we launched on Atlas Centaur, 9 pieces of hardware for the International Space Station, a number of missions, educational programs at the center. I was always a part of the Speakers Bureau because growing up, my inspiration was Apollo, and where I was from in northeastern Pennsylvania, one of the Apollo flight directors was born and raised about 5 miles from where I used to live. And I used to correspond with him from the time I was in 5th grade right through college. He always would respond to me. I still have most of the things he sent to me over the years. I did my senior thesis in college in information with the space shuttle that he sent me, which was before the shuttle even flew. So I always felt public outreach was very important. After all, it's everyone in this room who's paying for everything that NASA does. In 40 years, my own records show that I did over 300 presentations and events to over 30,000 people in that time frame.
Amen.
And we're going to talk a little bit about NASA's current state of affairs a little at the end of this presentation as well, because it's groups like yours that are going to become very, very important for the future. First, the OSIRIS Rex mission. Origins, spectral interpretation, resource identification, security, regolith, explorer. You know you've worked for NASA for a long time when you can talk with someone else and just use acronyms and not use a single word of English and you know what you're talking about.
Yes.
NASA does everything in acronyms. And if you have any questions as I'm going through this, feel free to raise your hand. We'll address questions here and also save time at the end. The primary goal of OSIRIS Rex was to get a sample of at least 2 ounces from an asteroid called Bennu. It is a carbonaceous asteroid. It actually does cross Earth's orbit. but it is an asteroid that was believed to be containing material that had been untouched since the formation of the solar system. It was launched in 2016, did a gravity assist of Earth in 2017 to increase its velocity to reach Bennu. It got there in 2018, and then it spent months analyzing the asteroid, getting closer and closer to it, learning how it was configured, how its gravity was, so it could get close enough to literally reach down and grab a sample off the surface of the asteroid. That was done in October of 2020. It did so well that over 1 kilogram of surface material from the asteroid was retrieved and brought back to Earth. And that sample was returned at the end of September in 2023. Now, Bennu was chosen because, as I said, it's a time capsule from the formation of the solar system. It has a very dark surface as seen from Earth, a B-type asteroid, carbonaceous, and they are considered primitive, having undergone little change since the solar system was formed. It was believed to have organic molecules because of its darkness and its high carbon content that told us how life may have evolved in our solar system. It's a rough spheroid. It's actually more of a diamond-shaped asteroid. Its rotation axis is tilted to the way it moves. Its surface is very rough, with boulders, the largest of which was over 158 feet across. And these boulders, as seen by the cameras on OSIRIS-REx, had veins of carbonate materials. These are believed to have formed when this asteroid was part of a larger body that had a lot of water, and it broke up.
How big is it? Jeff, question?
There you go. Mean diameter of about 1,600 feet. Very small. It was actually discovered in 1999. It is a potentially hazardous object because it does cross Earth's orbit, but its odds of actually impacting the Earth are infinitesimally small. Some observations shown that its rotation is getting faster, believed to be caused by the Yorp effect. I am not going to try to pronounce many of those names because I can't do justice for them. We're going to talk about that in a little bit here. But it's also affected by the fact that the thermal radiation from it, as it rotates in sunlight, is not uniformly distributed. And I think, as we all remember from basic physics, light has mass. And thermal radiation is infrared light. We don't see it, we feel it, we call it heat. But it's light, it's part of the electromagnetic spectrum. So there's a mass change happening, which will affect its rotation over time. Analysis, as the spacecraft orbited it and got closer and closer, it could actually map the gravity field. And what it found out is this asteroid only has a density slightly greater than that of water. Bennu is not a solid body. It's a pile of dirt, a rubble pile. If you can imagine taking a handful of dirt and having it stick together, that's what Bennu is. It is not a solid rock, if you will. It's a loose pile of rubble, which is why we were able to collect so much mass in the way of samples from it.
Did they know that before we just...
There were hints of that from radar scanning done from Arecibo, when, of course, we still had Arecibo. Many asteroids are like that. The Japanese, the Hayabusa spacecraft, the asteroid it visited, was also the same, a rubble pile. Many of them probably are rubble piles. You just didn't have enough material come together to form a more solid surface, but enough there to cause everything to stick together. The Yarkovsky effect was first discussed by a Polish-Russian civil engineer in the 1800s. We worked on scientific problems in his spare time. And he didn't have to exercise his thumbs on a cell phone back then. He actually could do something real. And around 1900, he noted that a daily heating of a rotating object in space would have caused it to experience a force that could lead to long-term effects. F equals ma. The force is small, the acceleration is small, but if it goes on for a long period of time, it has an effect. And this was only recognized by another astronomer, Ernst Öpik, who read his pamphlet in the early 1900s and kept the knowledge going. So this effect changes the rotation of small bodies because of how sunlight, the spectrum of sunlight, is scattered off the surface of it. Electromagnetic radiation, of course, covers everything from radio waves at the low end of the spectrum. You start moving up to this very, very narrow band that we see called visible light. At the low end of that is the red, and just below what we could see is infrared. We call that heat. Then you start moving to the high end, you get ultraviolet, which we don't see, but it burns our skin, and you start moving up that spectrum. You start getting into X-rays, then you start getting into radioactive gamma rays, etc., as you move up the spectrum. You know, microwaves are in there too, they're at the higher end. You know, when you cook something in a microwave, you're cooking with radio waves. They're at a frequency that water really likes. So those frequency waves cause the water molecules to vibrate, and that generates the heat that cooks the food in a microwave. So really, a microwave is just a radio. Another interesting effect, because of this rubble pile and because of the distribution of heat, is that Bennu observed it sporadically emitting plumes of particles and rocks out into space, just throwing them off the surface. Probably volatiles that were heating up and spewing these things out because it's so loosely held by gravity. And the heating of the surface being differential, heat would tend to flow into areas, get concentrated, and basically blow things off the asteroid into space.
Then the question.
Yes.
Did we know that it did that before this satellite went there?
No, no. That's a fact that's much too small to be seen in any way from Earth. The spacecraft itself was not very involved, not very big. 4,600 pounds at launch. Most of it fuel, as most spacecraft are. Dry mass of just under a ton. It would fit in this room, about 8 by 8 by 10 feet was the spacecraft. A complex system, of course, on the arm that was used to grab the sample and contain it. Solar arrays for power that could move to track the sun, and a high-gain antenna, as well as low-gain antennas to get data back to Earth. In the center there on the left, you see the SRC, which is the sample return capsule, which is how the samples were transferred from that robot arm to that small capsule to return to Earth. The arm, or the tag SAM as it was called, touch and go sample arm mechanism, had a hollow head that was used to grab onto the sample and restrain it once it impacted the surface of Bennu. There was a 5-second timer initiated when the accelerometers indicated the impact, and then would tell the spacecraft to start backing away. There were nitrogen bottles that would fire to make sure that when the impact occurred, obviously things are going to want to be thrown away from the impact head. The nitrogen bottles actually use dry nitrogen to blow things into the head. This was the trajectory followed by the spacecraft. You see the sun in the center. The blue line is Earth's orbit. The green line is Bennu's orbit. And you'll see the spacecraft slowly moving from Earth to going to its rendezvous. You see the speed down at the bottom there. And this should start over again pretty soon here. Come on. I know you start over. Now it's not going to start over. Why are you not starting over? I didn't think it ran this long. But you see the speed of the spacecraft at the orbit. There it is. It is launched from the Earth, going around the sun, and catching up to Earth again, right about here. So Earth's gravity could give it the boost it needed to go further out to reach Bennu. Traveling at a speed of about 24 to 25 kilometers per second.
Whoa.
Now in 18, the spacecraft went to its first orbit around Bennu about 12 miles above its surface. Remember, the asteroid is only 1,600 feet across. So it's orbiting 12 miles above the surface. As it continued orbiting, mapping the shape of the asteroid, mapping its gravity field, of course, those designing the trajectories were able to get it closer. They took it down to about 4 miles, where they could do spectroscopic analysis of the surface, found more of hydrated clay minerals, clays that form only in the presence of water, which again supported the theory that this was part of a body that once had a substantial amount of water. It brought down its orbit to about a mile above the surface of the asteroid. And even at that altitude, because of the low gravity, which of course defines how much speed you need to orbit it, it took it 62 hours to orbit Bennu. I'll tell you, that asteroid it was a hollow rubble pile. It was the closest distance that any spacecraft had orbited since the Rosetta mission, which orbited 67P, and again, I'm not going to try to pronounce them because I can't do them justice, about 4 miles above. And at the end of the survey, the orbit was brought down to about a half a mile above the surface of the asteroid in preparation for grabbing a sample. And in the years it took doing that, if we do it at high speed, we can look at how those orbits were done. Higher, lower, mapping, doing spectroscopic analysis of the surface to look at the composition, to determine where the best locations were for the impact to grab samples would be, gravity mapping, etc., thermal mapping, photography of those ejection events that I was talking about.
So, question.
Yes.
So this is while the asteroid plus the spacecraft go like 25 kilometers a second around the sun while this is happening. Wow, that's pretty.
Look, I mean, even now, I mean, sitting in this room, we're all moving at 67,000 miles an hour, because that's how fast the Earth is moving around the sun.
Woohoo.
And no tickets either.
No tickets.
Well, after all this photography and sampling, the science team selected 4 potential sites, both located within small craters on the surface of the asteroid, somewhere near the North Pole, somewhere near the equator. They eventually settled on the Nightingale site, which was near the northern pole of the asteroid, and started doing approach missions to get closer and closer and closer for the event. You have to understand, with the distance from Earth to this asteroid, you're not controlling the spacecraft because of the time lag for a radio signal to reach there and come back. It all has to be pre-programmed. The spacecraft has to do it by itself. If it runs into a problem, it has to correct that problem and recover from it by itself. So all this has to be figured out, exercised, and then a program uplinked to the spacecraft for it to execute. So there were rehearsals done bringing the spacecraft down as close as 65 feet from the surface before doing the back-away maneuver, and a second rehearsal was done bringing it down to just 40 feet from the surface. This was an artist's conception of the spacecraft maneuvering to bring that TAGSAM head down to the surface. You see the solar arrays, how they've been angled up so that any material kicked out from that impact would not damage those solar arrays. This is video from the sample collection camera on the spacecraft as it approached for that touchdown. It hit its target within 3 feet of where they planned. Looks just, it's a pile of rocks.
It looks like dirt.
It is.
I mean, just dirt.
It is.
Yeah.
Everything in the solar system, including the sun, was formed from the same nebula. So a field of rocks on the Earth should look like a field of rocks on Mercury, on Venus, on Mars, on Pluto, because they're all the same materials. The differences tell us how they evolved, whether there was water there or not, what kind of an atmosphere may have existed or not. So those are higher level differences, but at the basic level, basic types of rocks, whether it's here or Mars or Bennu, it's the same. I think most people expect to see green rocks or something, something extraterrestrial.
Yeah, glowing maybe.
If you saw that, it's probably fake. If it doesn't look like what you find here, then it's not real.
Although it's most likely regolith, right? I mean, there's no atmospheric.
No, there's no atmosphere, although this surface is rich in organics. And this is from the camera on the sample arm itself. It actually penetrated 1.5 feet into the surface of the asteroid, created its own little crater. So it worked better than anyone could have ever hoped for.
Is that bouncing off? Is that what we're seeing?
Is that the nitrogen?
What you're seeing there is the impact, the nitrogen jets firing, and then those accelerometers telling the spacecraft to back away. Because yes, we hit. You can start going the other way.
What's the timeline there?
From the point it first encountered the surface to the back away was about 4.5 seconds.
Oh,
Whoa,
that's quick. Okay.
that's quick.
So that's not real time.
Oh, no, no. No, this is all accelerated. And when the arm was raised, when the spacecraft was moved out, the arm was raised, they did such a good job that material was actually leaking out from the capture head because a mylar flap that was supposed to have sealed to keep the sample in, there was so much sample it didn't seat in all those places. But they got so much and it just didn't really matter. They, when the head was seated in the sample return capsule, they did what was called a back-out check, basically tugging on the arm to ensure that the latches holding that sample head in place were secured, and they were. They were going to do a spin of the spacecraft to try to measure how much material had been captured, but they worried that spin might cause them to lose material, so they stopped. They decided not to do that. Over a period of a few hours, they basically severed the collection head from the arm and then pulled the arm away and sealed the lid on that sample return capsule. Now again, we're not talking anything very big. The capsule itself, about 80 by 50 centimeters. Remember, 1 inch is 2.5 centimeters. So that 50 inches is about, what is that, a little over 3 feet high? So we're not talking a very big capsule here. But you see the latch mechanisms, the hinges. It did have an avionics deck because it needed that to sense deceleration in Earth's atmosphere to know when to deploy parachutes. Unlike, I forget whether it was Stardust or Genesis, when it returned its samples. The chutes never deployed. They found out the accelerometers were put in the sample return capsule upside down.
Oh.
So they didn't register the deceleration.
Did they retrieve those though?
Yes, they did retrieve it, and there were samples that were actually able to be analyzed. It didn't survive impact intact, but intact enough where some of the samples were able to be used. The spacecraft actually captured samples in what's called aerogel. So those samples were actually kind of sealed in the aerogel. So a lot of them were contaminated by Earth's atmosphere. A lot of them were not. So there was still useful material. There you see the head being lowered into the sample return capsule, and there you see that it sealed. The samples were brought back at the Air Force's Utah Test and Training Range and taken to NASA's Ares Lab and Japan's Extraterrestrial Sample Curation Center. They were distributed worldwide, including samples were sent to China for analysis as well. The spacecraft, when it did a flyby of Earth at about 60,000 miles above the Earth's surface and released the capsule in the right direction so it would enter the Earth's atmosphere. The spacecraft then increased its speed to fly off for another mission. The capsule entered Earth's atmosphere at about 400,000 feet, moving almost 28,000 miles per hour. At 102,000 feet, the canister cover on it was ejected and a drogue parachute deployed to stabilize it. And about 5,000 feet above the surface, the main parachute was deployed. So it went from a speed of almost 28,000 miles per hour to landing on the floor of the Utah desert at about 11 miles per hour. And why bring it into Utah? Well, you have a major empty area that's 2.3 million acres, so if you missed your target, odds are you're still not going to hurt anybody or anything. But it landed almost right in the middle of that landing ellipse. And these are pictures of the landing of the return capsule coming down on its chute and the capsule sitting on the floor. It ejected the chute, so of course wind wouldn't drag it. Once the accelerometers registered 0, pyro separated the chute from the capsule. And it was completely intact.
I probably shouldn't have watched Andromeda Strain when I was a kid, right?
Oh, that's a great movie.
Yes,
That's a
it
great
is.
movie, yeah.
Yes, it is.
This is the sample capsule at JSC. The biggest problem they had was getting at the samples because they couldn't get the bolt screws.
Oh.
It took them a long time to get them, but they finally did get the cover removed. But here you see material actually external to the capsule, that sample container. There was so much of it that had been grabbed. So analysis was done on everything that was retrieved. Within the first 2 weeks, the quick look showed chemical analyses of a high carbon content. There were 3D computer models done of a lot of the particles to look at how they were put together. It was very rich in carbon, nitrogen, organic compounds, all of which are essential for life. So a lot of these materials probably brought the seeds for life to Earth when Earth first formed. You know, we see the evidence of impacts on the moon because it has no atmosphere, so those craters are all still there. Earth has just as many craters, but we have an atmosphere, so those get eroded over time. We don't tend to see them. But these asteroids and comets were the seeds that caused life to evolve on this planet. There was a high degree of clay minerals, the same types of materials that are found at mid-ocean ridges on the Earth. So again, it confirmed that this was a body that came from a world that had a high water content. What happened to that world, we don't know. It broke up for some reason. Could have been another impact by another body. Earth's moon was created that way. When Earth was still molten, an object about the size of Mars impacted the Earth. The material was thrown off the planet. What didn't fall back on the Earth came together to form the moon.
Cool. Did you know that?
Now, the phosphates on these were very interesting because there was a much higher concentration. The asteroid Ryugu, which was, had a sample delivered by the Japanese Hayabusa 2 mission, showed the same material, but not the same quantity and not the purity of it. So they may have had similar origins, but Bennu was closer to the source of the water. Despite its interaction with water, it still maintained that same chemical equilibrium when the solar system was formed. The proportion of elements in it actually resembled mostly those of the sun. So again, it's a time capsule of when the solar system was formed. Samples are continuously being distributed around the world. There are a lot of papers being published, some of them literally just in the last few months. August 2025 in the journal Nature suggested that Bennu's ancestor broke apart in a violent collision. It has materials from a number of distinct environments in our solar system and possibly material that actually formed in interstellar space. They look at isotopes of the elements in the dust, and the isotopes of some of these match what's in our solar system. Some do not. So those indicate that they were from outside our solar system. So they believe the parent asteroid may have formed likely beyond Jupiter and Saturn, and then some event happened where it was struck by another object, and after the initial impact, some of the fragments came back together, maybe even happened more than once. And eventually, some of them came together and formed the asteroid Bennu. Picture on the right is a scanning electron microscope image of one grain segment, which shows a micrometeorite impact crater in that asteroid. So even asteroids that hit larger bodies were impacted by smaller bodies. Reminds me of a limerick that I've heard. Big fleas have little fleas upon their backs to bite them, and little fleas have smaller fleas, and so ad infinitum.
I like it.
Second paper compared it with the samples from Ryugu that came back to Japan. They were very similar, but again, Bennus were changed by water contact. Bennu's parent asteroid actually accumulated ice and dust. Eventually that ice melted. The water reacted with the dust to form what we see today. Clay, that is 80% minerals that contain water. And again, the impacts of these micrometeorites, those left behind small craters and impact melts. So again, we can look at the spectroscopic composition of those materials from about where they melted from the microscopic impacts. And that layers the materials, so we have a better idea of the composition. Ain't science wonderful? And also, 6 boulders on the surface of them, ranging in size from about 5 to 14 feet, are brighter than those typically found elsewhere on the asteroid. They actually match the composition of material from the asteroid Vesta in the main asteroid belt. So something hit Vesta, some of its surface material actually came to rest on Bennu. Just like we have asteroids that have been retrieved on Earth that we know have come from the moon, that have come from Mars, because their composition matches the composition of what we know of the surface of the moon and the surface of Mars, but not the surface of the Earth. Same thing has happened here. Now again, Bennu wasn't the first set of samples brought back. The Stardust spacecraft returned particles from the tail of the comet Wilt-2 in 2006. Hayabusa, the first one, returned samples of Itokawa in 2010 and Ryugu in 2020. Genesis, solar wind particles in 2004. OSIRIS Rex, of course, brought the samples back in 2023. There were other potential missions that were bid. One was called Caesar from the Goddard Space Flight Center. It was up against the Dragonfly spacecraft for the New Frontiers competition. The Dragonfly beat out the Caesar mission. I think Dragonfly is going to launch in 2028. It's a drone, an octocopter that will fly in the atmosphere of Saturn's moon Titan, land on the surface, do scientific analyses, start its rotors up, go to a new location. Wow. It's going to be interesting to operate a drone where the atmospheric temperature is 450 degrees below zero.
Whoa.
Johns Hopkins University had a similar mission called Corsair, which would have been a 10-year mission to another comet out near the orbit of Mars. The Japanese Space Agency had been planning a mission to return samples from Phobos and conduct close flybys of Deimos, the 2 moons of Mars. And the Chinese are targeting a South Polar mission, Chang'e 6, which they did land near the South Pole and actually returned South Pole lunar samples to the Earth for the first time. And some of those samples were shared with NASA.
Cool.
Anyone have, that's OSIRIS-REx. Does anyone have any other questions on it before we go over to the DART mission?
If that asteroid would have entered Earth's atmosphere, would it just dissipate and melt and fly away, or what? Or would it have enough impact to, really cause damage?
It's hard to tell because it was so loosely held together. There were so many volatiles in there. What probably would have happened, and we'll talk about it here, is it probably would have exploded in the upper atmosphere. And that by itself could cause a huge amount of damage.
And we're actually going to talk about that here again. You're perfect, straight questions that lead me right to the next slide. I love it. And I didn't even have to pay anybody for it.
I was gonna say, give me $5.
Now, of course, when our solar system formed from the solar nebula, the sun, planets, moons, planetoids, asteroids, comets, there's still a lot of crap out there. Dust particles, rocks, boulders, throughout the solar system. And some of them are a danger to the Earth. Again, we can look at impact craters on the moon. We can look at impact craters on Mars. We can look at impact craters on Mercury. We know impact craters on the Earth, even though most of them have been eroded by atmosphere, wind, weather, etc. But we've been smashed into. You know, it's not a question of if a large impactor is going to hit Earth. It's a question of when it's going to hit Earth. In 2013, the Chelyabinsk meteor was a small one. It was about 20 meters across. Okay, so it was about 60, 65 feet across. Bennu was 1,600 feet across. It was small. It was only 12 to 13,000 kilograms, so it probably weighed on the order of 50 to 60,000 pounds. It entered Earth's atmosphere at a speed of 19 kilometers per second. The light from the meteor was brighter than the sun. It was visible up to 100 kilometers away. It exploded at about 30 kilometers altitude with a blast yield equivalent to 400 to 500 kilotons of TNT. That was larger than the atomic warheads that were used in World War II. About 1,500 people on the ground were injured from the shock waves from that explosion, and 7,200 buildings in the region were damaged by that shock wave. This is from an object exploding 18 miles above the surface of the Earth. So imagine something like that coming down onto the ground in New York City, in London, in Paris, in Tokyo, in Washington, D.C. It might not be bad in Washington.
Yeah.
Imagine it's just an air burst like that, but over New York City, and glass coming from skyscrapers falling down onto the crowds. Doesn't have to be a surface impact for it to cause problems.
Question, when that says that was undetected before entry, that means
Yes.
before this bright light, no one knew it was coming?
Right, it was too small to be detected.
It was coming from the sun side.
Yeah, we was ambushed.
That same day, they were actually waiting for another asteroid
Yeah.
to pass close by,
Yes.
and all of a sudden, boom, on the other side of the Earth, an asteroid hit. So did we calculate it wrong?
Yeah,
There's actually two asteroids.
there were larger asteroids that we've tracked that actually have come between Earth and the Moon in orbit, passing the Earth. NASA's Center for Near-Earth Object Studies, as of February 2025, has identified over 37,000 near-Earth objects. Of those, about 2,500 are considered potentially hazardous. We track these with optical systems, with radar systems where we can. None are confirmed to hit Earth for the next 100 years, but there are many that come very close. In February 25, this one asteroid, 2024 YR4, has a 2% chance of hitting the Earth in 2032. This one is worrisome enough in that the Webb telescope is monitoring it to get a better track on its orbit. I'm sure everybody has heard about Apophis. In 2029, it will pass Earth closer than some of our satellites orbit the Earth. Its chances of hitting are currently predicted to be 0. But this could change if it's altered by coming close to another body in space, or that Yorp effect starts to affect it in some way. Apophis is large enough and dense enough that it could cause what is literally an extinction level event.
Great name, then.
As of end of September 2023, this shows over almost 33,000 near-Earth asteroids discovered, 120 comets, 850 asteroids larger than a kilometer, 2,366 potential hazard potentially hazardous asteroids. 5 times a year, on average, a small asteroid impacts the Earth and releases energy greater than 1 kiloton of explosives. And 112 known asteroids passed closer to the Moon in the year that this data was generated. So the garbage is out there. It's a threat. And we're just beginning to be able to do something about it. Asteroids are classified in 4 categories. Earth-approaching ones, but with orbits outside Earth's orbit. Some of them will cross Earth's orbit. Some have orbits that are smaller than Earth's, and some of those are smaller but will cross Earth's orbit. So as you can imagine, those that cross Earth's orbit are the ones that are the primary concern for being potentially hazardous objects. An object about 10 meters in size hits the Earth about once every 10 years. And of course, the larger ones is a longer period of time. But when you look at those smaller ones, 10 meters and 50 meters, they can cause devastation. And we haven't been able to discover a lot of those because they're so small. Our ability to detect these objects is limited. The bigger ones, yeah, we can see those, we can track those. But the smaller ones are much harder. And that's what drove the DART mission, Double Asteroid Redirection Test. One possible way to deflect an asteroid is to slam into it, change its orbit. You provide an impulsive thrust to actually alter its orbit. The question is, it looks good on paper, but could it happen? Could we do it? Well, this was a test of that. It was a binary near-Earth asteroid called Didymus, which was the target for the DART. And then we found out that Didymus had a smaller moon called Dimorphos, about 160 meters, about 350, 400 feet in diameter. So that binary was observed using Earth telescopes. The images on the right are actually radar images from Arecibo, and the image on the right is actually from the DART spacecraft as it was approaching that asteroid system. It did achieve the deflection it set out to do. It crashed into Dimorphos at a speed of about almost 15,000 miles per hour with the aid of a camera and an autonomous navigation system. Again, you're so far from the Earth, you're not controlling this from the Earth. The spacecraft has to do it by itself. And the collision changed the orbit of Dimorphos around Didymus. It was launched from Vandenberg on a Falcon 9. It was about a year cruise that intercepted the asteroid in late 2022 when it was about 11 million kilometers from the Earth. This was observed by, of course, the spacecraft, by ground-based telescopes, space-based telescopes, to see how well that impact was doing what it was supposed to do. And again, these are just some artist conceptions of the trajectory of the spacecraft hitting Dimorphos. Before the impact, it deployed a small CubeSat called Lycia that was provided by the European Space Agency as part of the Hera mission, and it actually observed the impact as well. Prior to impact, Dimorphos orbited Didymus at about 12 hours. And the separation between the centers of the two asteroids was about 3/4 of a mile. DART hit Dimorphos nearly head-on. So it would shorten the time it took that asteroid to orbit Didymus. The mass of the spacecraft at its time of impact was about 1,200 pounds. And the mass of Dimorphos, of course, you can't directly measure it, but by looking at the asteroid's density and size from telescopic observations, measuring its orbit very accurately, its mass was estimated at roughly 5 billion kilograms. So it's not a rubble pile. It was a solid body, or so we thought.
Or so we thought.
DART was a very small spacecraft. Only about 6 feet wide, 6 feet tall, 8.5 feet high. 2 very large roll-out solar arrays to power it. It had a camera and a navigation system, and that's about it. It did have one other thing. You see on the very top, the next engine. Next is an ion engine, the NASA Evolutionary Xenon Thruster. Most people don't realize that we were able to visit Ceres and Vesta in the main asteroid belt with one spacecraft because of an ion engine that powered it. That ion engine was developed right here in Cleveland at the Glenn Research Center.
Cool.
Ion engines were invented at the center here in Cleveland in the late 1950s. They did not fly as the primary propulsion system on a spacecraft until Deep Space One in 1998. That's the speed of government.
How does that work?
The ion engine is a very low thrust system. It heats a rod called a cathode, and xenon gas is inserted into the engine, and it's heated very quickly, so it ionizes it. At the end of the engine is a magnetically charged grid, which accelerates those particles out to provide thrust. Now, when I say low thrust, we typically measure the thrust of an ion propulsion system in units of mmf, milli mouse farts. If you take a sheet of paper, hold it 2 inches above the tabletop and drop it, the force of that paper hitting the table is the force of this thruster.
Millie Mouse farts.
But F equals ma. You run this thruster for a long time, and you can develop speeds much faster than you can with the high thrust system. We measured the efficiency of a rocket engine in terms of something called specific impulse, and its units just happen to be seconds. You look at a high thrust system like the Space Shuttle main engines, the most efficient engines we ever built, liquid oxygen, liquid hydrogen, high pressure, had a specific impulse of about 450 seconds. An engine like this has a specific impulse of 3,000 to 5,000 seconds.
Whoa.
Much more efficient. So you're sacrificing time for efficiency. You're not going to use this for human missions because you don't want to sacrifice time with humans. But for a scientific mission, let it take 2 years to accelerate. Who cares? I could do it for 100 kilograms of xenon instead of 20 tons of liquid oxygen and liquid hydrogen. Smaller spacecraft, simpler spacecraft, smaller launch vehicle, cheaper mission.
Now, couldn't you hypothetically increase the power source for an ion engine and scale it up to
Yep.
a larger spacecraft that could carry humans?
The center here in Cleveland, back in the 60s, developed and test fired in a vacuum chamber an ion engine. If I remember right, it was 6 feet in diameter. It was huge.
Nice.
Yes, you could.
Okay.
This next engine, too, had another important fact in that it was throttleable. You could vary the thrust of it by applying more or less power to the system to do exactly what you're saying.
Nice.
And there are other types of engines. There are Hall effect engines, which provide a higher level of thrust. They are ion engines, but they operate differently. And there are engines that combine an ion engine like this, which is called an electron bombardment engine, and a Hall thruster. So you can have a higher range of throttling capability for missions. So yeah, what you said is exactly doable, yes.
Awesome.
Well, what kind of thrust do you get from that 6 foot across ion engine?
Oh boy, I don't remember.
Talking reams of paper or something like, more like a
I think
a
the thrust
rocket
was,
blasting
I think the
off?
thrust was on the order of a few newtons in force, like a third of a pound, half a pound of thrust, but not milli ounces of thrust.
So we could accelerate a mouse.
Exactly.
What he said?
It could accelerate a mouse.
Accelerate
right.
a mouse.
The flatulent mass.
But this is the spacecraft at Johns Hopkins University's Applied Physics Lab in Laurel, Maryland, which did this mission for NASA. This is the spacecraft being assembled in the clean room, and you see the next thruster being installed on top of the spacecraft. For launch, it had what they refer to as a top hat put on it, just to protect it, because the spacecraft on the launch field was actually mounted upside down. So the top of the spacecraft is actually at the bottom of this photo. The bottom of the spacecraft is at the top. And this is the approach to the asteroid. coming from the DART spacecraft, getting closer to the surface, and telescopic observations of the impact from Hubble and Webb space telescopes. This is from that Lycia CubeSat, and you can see the impact registered by its imaging system. This is the ejecta from it. This was 2 days after DART's impact of that asteroid. This is from Hubble Space Telescope 12 days after the impact. So all in all, it was a very successful mission, and it changed the orbit of that asteroid much, much more than we could have ever thought. There's only music, so I didn't bother with speakers. This is actual imagery. It's accelerated, but this is the imagery from the impact. Again, that next engine was a test of the engine. It was not needed for the mission. It was fired in deep space, and it did help get the spacecraft to the asteroid, but after that it was shut down. And this leads up to the follow-up program that ESA is conducting called HERA. DART was actually part of the HERA program, and so was the Lycia cube that it carried. Both of these missions comprise what is known as the Asteroid Impact and Deflection Assessment, or AIDA, collaboration, to look at deflection of a hazardous asteroid by a kinetic impactor. The orbit of Dimorphos around Didymus, they had hoped to change it by a few seconds. The orbit was changed by almost 12 hours. That's how successful the impact was. Again, this is the Hera spacecraft, which was launched a few years ago, being put in the Ariane 5 for its mission. It's not a very large spacecraft either. Solar powered, again, spectroscopic scanners, high resolution imagery, high gain antennas to get the information back to Earth. It's going to look at the after effects of Dimorphos and Didymus in that system. In other words, after X number of years have gone by, what are the long-term effects of that? These are some of the reference materials, and again, this is in there. You can look up. These are the press kits and fact sheets on OSIRIS, REx, and DART, as well as Japan's Hayabusa, and the Hera mission launch kit, which gives you more information about the spacecraft, the instruments it's carrying, and the mission it's going to be doing.
So what sort of calculations have been done on how big of an asteroid could be diverted at all?
Again, that depends on the size of the impactor, how fast it hits the object, because remember, it's momentum,
Right.
not mass, that causes the change. How far out from Earth you can detect this object and how soon you can intercept it. Testing? Okay. I must have hit something wrong. All those things have to come together. You know, something the size of like the Chelyabinsk impactor that exploded in 2013. We couldn't even detect it. So all those things have to come together. There also has to be a seriously funded effort to do it. And a big enough effort to do that is not in place, and it's not likely to be, because this is still looked on as the realm of science fiction, thanks to a lot of bad movies that have been done over the years. But it's not science fiction, it's fact. As I said, it's not a question of if the Earth is going to be impacted. It is a question of when. The one thing in our favor is that Earth is 70% water. But a large impactor hitting the ocean is going to create tsunamis that could be hundreds or thousands of feet tall. So you might want to consider buying oceanfront property in Nevada right now.
Would you explain the difference between the mass and the momentum? I always think of mass, just something ramming into it. So explain the difference.
Momentum is a measurement of the energy of an object when it is in motion. So it's dependent on the mass and how fast it's moving. So kinetic energy is 1/2 times the mass times the square of the velocity. So the velocity is actually more important than the mass. Space Shuttle once had to have one of its main forward windows replaced because it hit a flake of paint in orbit. It actually put a crater in the window. Because when you have the orbiter moving 17,000 miles an hour in one direction, and that flake of paint is moving at 17,000 miles an hour in the other direction, you have an impact at 34,000 miles an hour. And it may just be a flake of paint, but the energy imparted is massive because of the velocity. Yeah.
So how are we keeping all those satellites up there with all that junk is in space?
Satellites have been impacted by micrometeoroids. The International Space Station has hundreds of micrometeoroid impacts. You design the spacecraft to survive them. The International Space Station, the pressurized modules are actually multiple layers. So there's a layer on the outside that when an object hits it, it will slow it down and that object will fragment. And then there are layers of blanketing below that. So as it goes through the next layer, it'll fragment smaller, 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 dissipating energy so it doesn't reach that critical pressurized layer. It's called a Whipple plate, named after the man who first suggested doing it. Apollo spacecraft was built the same way. Any human-rated spacecraft is built that way to withstand those impacts.
How big of an impact could it take? I mean, you can't have it too big, otherwise the spacecraft's too heavy.
Exactly right, yeah.
What
You
do
can't-
they design up to?
They design it for basically dust grain-sized particles.
Dust grains, okay.
Anything much larger than that, and you're playing statistics.
So if if a penny hit, it would go right through.
A penny, yeah, we'll go right through it. We'll go right through it, yeah. Again, if it had the right velocity, hitting at the right angle and such, yeah. If it hit at a very oblique angle, it might bounce off. It's going to cause damage, but it might bounce off. But a straight impact, you know, if I'm going 17,000 miles an hour that way and somebody has a penny going 17,000 the other way, yeah, it's going to go right through. As a matter of fact, that was considered a way to remove orbiting satellites of hostile partners by putting debris in orbit, but in the opposite direction, and just let it slam right through them. Yeah. We're wonderful, aren't we?
Of course, then that affects the aggressor in the future. They have to try to keep track of all that.
Details. But you know, missions like these, science missions, in the future here, it seems likely you're not going to see them. They're going to be eliminated. Because currently, NASA is being gutted. Science missions in the president's budget are eliminated in favor of creating a fictitious space race with China. Literally thousands of NASA senior management, science, and engineers have either been forced out or left the agency. There's about to be what's called a reduction in force for NASA and other branches of the federal government, something that hasn't happened since about 1972.
To what extent have people in your line of work in the last 10 or 15 years actually been replaced from young people as your generation?
Not enough. Not enough.
So this has been going on a long time.
Yeah.
Brain drain.
Yes. Yeah. And the same is happening to the contractors that support NASA. They're losing a lot. The current administration is actually controlling what science is done because they don't want it done. And it's turning into an autocracy, is what it is.
So focus on exploration means manned missions.
Mm-hmm. Boots on the moon, putting a flag there. No real reason for doing it. The real reason for going back to the moon is a stepping stone so that humanity can continue to move further out. Because unless we become a multi-planet species, we're not going to exist. Because as I said, sooner or later, either we're going to destroy this planet or something is going to destroy it. It's not science fiction, it's science fact. And organizations like yours are going to be very critical to make sure that the public understands these things, that they are real, that they are scientific fact. And one thing I wanted to do tonight here is actually I want to give something to Ron here. It's a certificate I've done because I believe what you're doing here is very important.
What about wormwood mentioned in Book of Revelation? When's that supposed to get to your
I'm not sure, to be honest with you. This is extending my appreciation to the Astronomy Club of Akron for the outreach it conducts to raise awareness of the science of astronomy and the majesty of the universe. And in it here, I have your logo with a basically a model of the mirror, the Webb Space Telescope.
Right.
So, that's for you and your group. You are really going to be at the center of making sure that a scientific dark ages does not happen in this country. Literally, you are going to become more important than you ever have been for your entire existence.
Wait.
As far as we know, are the Chinese doing the same thing of focusing on man instead of science?
No, they have a science program. They've sent several lunar landers. They have rovers on the far side of the moon. They've brought samples back. They are looking at Mars missions. They have their own space station now. Somehow, for some reason, we see that as a threat to us. It is not. As we move further out into the solar system, we cannot do it as a single country because we can't afford it. We've got to do it as a world. And the idea of doing it in a military fashion is utterly asinine. We're taking the problems we've created on this planet and taking them with us as we move out into space.
Are you talking about Space Force or what?
Yes, yes. NASA recently had taken away its ability to have union representation. It has been classified as a security and counterintelligence group. So it has no right for union representation anymore. Also, the president announced that Space Force's Space Command headquarters is going to be moved to Huntsville, Alabama, which is where the NASA Marshall Space Flight Center is. I honestly see this as the administration's going to bring NASA to an end. Space exploration will come to an end. It's a complete violation of the National Aeronautics and Space Act of 1958. The acting NASA administrator has talked about claiming the moon for the US, which violates a treaty that was signed in the United Nations in 1967 by the United States. But they don't care.
So what else is the European Space Agency doing?
They have their own space program. They have their own space program. The Indian government is having their own space program, including developing their own human-rated spacecraft. The United States will not be a leader. The United States has not been a leader in anything for decades. It's been fiction. What we need to do is work together as a planet. And unless we have politicians that can realize that, this country itself won't exist in the next century. There's a group out there called Titans of Space, which I stumbled upon, but I've become involved with. It is looking at the contributions, not just of NASA, but of the people of Cleveland who've worked in the space program. It's losing a lot of potential funding avenues because of what's happening, but we're still trying to keep it afloat. We're still trying to do things. So this is their website, titansofspace.org. There are interviews with people on there who have been critical to space exploration that most people here, you probably don't even know about. The first NASA leaders all came from Cleveland. T. Keith Glennon, the first NASA administrator, was head of the Case Institute in Cleveland. Abe Silverstein, Edgar Courtwright, George Lowe, and you already heard me talk about Glenn Lunny. They all worked at the center here. Abe Silverstein became the head of the Office of Spaceflight. He was responsible for the Mercury program. He laid the groundwork for Apollo. He named the Apollo program. Edgar Courtwright oversaw the development of ion propulsion at the center here. He became the lead for all of NASA's unmanned satellite programs. George Lowe was Abe Silverstein's deputy. He headed the effort on the development of the Saturn V, and he laid the groundwork to go from Mercury to the first lunar landing. The reason, when John Kennedy made his speech to Congress and laid down the challenge of landing a man on the moon by the end of the decade, human spaceflight experience in the US was Alan Shepard's 15-minute suborbital flight. He was able to make that challenge because he knew we could do it, because George Lowe, Abe Silverstein, T. Keith Glennon, and others had already laid the groundwork. They knew what it was going to take, how they were going to do it, and how much it was going to cost. Those are all people from Cleveland. The NASA symbol, the seal, and the logo, which we call the meatball, were both created here in Cleveland. James Monterelli created the NASA logo that you see on the bottom right there, that we all are intimately familiar with. It was created here in Cleveland. And from the beginning of the space agency to the late 1990s, the center here in Cleveland managed the Atlas and Titan Centaur launch vehicles for the agency. We were responsible for over 100 NASA missions. We were the ones who launched the Voyager spacecraft, which are now in interstellar space, the Viking landers, Pioneer spacecraft. I was ascent trajectory lead for 2 weather satellites we launched for NOAA in 1994 and 1995. That capability was taken away from the center and moved to Kennedy in 1998. The last mission that we managed was the Cassini mission, the launch of that mission to Saturn. So Titans of Space has dedicated itself to making sure that the people of Ohio know the history of what has been done by NASA and how critical the center here in Cleveland and people from Ohio have been in that work. So I would really encourage you to go to that website. I think you can send questions through it. If you do, a lot of them are probably going to come to me. And if you would like to become involved in any of the efforts, we'd love to have it, either individually or as an organization. So with that, I will thank you very much. You came to listen to me instead of being out on this gloriously beautiful day, and I appreciate that very much. So if anyone has any other questions, thank you.
This is kind of a nasty blue sky. Is there much talk or concern that something will happen, in hostilities that glitters the satellite space so bad it becomes almost impossible to do.
Yes,
research.
I would have to say yes. And then what do you do about that? You know, I did a presentation on what's called NASA spin-offs and technology that were developed for the space program that we use every day. And I hearken it to the movie It's a Wonderful Life, where, you know, the character James Stewart portrays gets to see what life would be like if you never existed. What if NASA never existed? Okay? Take your cell phones, throw them out. Take these computers, throw them out. All the computer controls in your cars would never have existed. You turn on the weather on the news and you see the satellite imager. Would never have happened. GPS would never have happened. If you had a medical condition where they couldn't figure out what was going on, you'd have to have exploratory surgery because CAT scans and MRIs wouldn't exist. You wouldn't have lives saved by smoke detectors and CO detectors in your home because they wouldn't exist. All of those are spin-offs from what was developed for NASA.
Digital cameras too.
Anything digital, anything digital. Computers were the size of a room. You know, there was a reason why it used to be called a computer bug, is because roaches used to get into the computers. The driving need for small computers was the Gemini program and Apollo. You have to understand, the computer that landed Neil Armstrong and Buzz Aldrin on the moon was a 12-bit computer. Not bytes, not kilobytes, not megabytes, 12-bit computer. There's thousands of times more computing power in your cell phone than what landed us on the moon. But we did it. But we did it. Yes, ma'am.
Going back to that thing that hit the asteroid that you guys weren't expecting it to affect it that much.
Mm-hmm.
You said that the asteroid basically, or the thing that crashed into it basically had to control itself.
Mm-hmm.
So did it have a computer, like, do a diagnostic and
Yep.
decide where to hit it to have the most effect?
Yes. Yeah. Keeping it on target, keeping it pointed in the right direction. Also making sure that it's pointed in the right direction to get data back to Earth.
Was the ion engine used for pointing or other engines?
No, it was just the first test actually in space of that engine. It was done while the spacecraft was going to the asteroid, so it actually shortened the amount of time it took to get there. It wasn't needed to do the mission. We were just able to hitch a ride and demonstrate it in space.
Is the OSIRIS spacecraft still up there, or did it ever actually return?
No, the OSIRIS spacecraft is still out there. It's being targeted actually to another asteroid.
Okay, it'll be dropping stuff off. just
No,
like
nothing to drop off, no. That was one shot, but its instruments are still working, so it can still do spectroscopy, other orbital analysis, flyby analysis.
Just nothing's returning home.
Correct, yeah.
Well,
Just like New Horizons and its flyby through the Pluto system, it's flown past other asteroids, they put it to sleep, and as it approaches other Kuiper Belt objects, they'll wake it up again if there's funding to do it,
Yeah.
and analyze other objects, yeah.
So OSIRIS-REx will do the same thing once it passes its next target. It'll-
Again, if there's funding to do it.
If they can,
Yeah.
point it somewhere else.
Yes, yes, yes.
Just a question. For the ion hardware and that other stuff, was that actually preliminary constructed and tested at Plum Brook?
No, those engines were tested in vacuum chambers right at the center here in Cleveland.
Oh, okay.
The vacuum facility, the Space Environments Complex out at Plum Brook it's the largest vacuum chamber in the world.
Okay.
It's 100 feet diameter and 122 feet tall. It has a vibration table that can handle a 75,000 pound spacecraft 75 feet tall.
Jeez.
Has the most powerful acoustic chamber in the world. In the empty chamber, you can create sound pressure levels of 162 decibels inside the chamber. So when a spacecraft comes in there, it can do all the environmental testing necessary to say, yes, it can fly, and you can pack it up and ship it to the launch site. It's the only place in the world that can say that.
Wow.
Yes?
So in terms of the sample return, all the volatile substances you have analyzed as well?
Yes. Yes.
Okay.
Yeah.
I was wondering, is it only solid, and when we open the sample chamber, if the volatile sample, some volatile substances?
Again, there would be heating, but as soon as that chamber was opened, Again, the whole capsule was put inside a vacuum tank.
Okay.
So as it was opened, if any volatiles were collected, and they would be analyzed as well. But you know, rocks down to micrometer-sized dust particles.
There's no cooling in the collection chamber, right?
Probably a small degree, but again, it's a vacuum inside the chamber. So you're not going to get any conduction. So any volatiles that come off would be gathered and analyzed.
So what about any liquid that comes up on the existing solid there?
I don't remember reading anything about like any liquid water that may have come off. I think what it is, the water is there. When we talk about water, like we talk about water on the moon,
Right.
in those craters, some of it may be there in terms of ice, but it's hydrated minerals. It's hydroxyl compounds that are combined, so you have to separate those.
Right.
I mean, there are ways to do that with heat or chemical reactions to separate the water from those. And it'll help us learn to do that, too. One of the experiments on Mars was actually processing the Martian atmosphere, which is mostly carbon dioxide, with chemicals and what's called a Peltier process to create oxygen. And that was successfully demonstrated on Mars. Very small quantity, but measurable. So we know the process will work. Anyone else?
Thank you.
All right, thank you very much.